Okay, today we're going to do 6-1 Part B. This is going to be finding the length of an arc. And it's a simple little formula. It's basically S equals the radius times the degree, the theta, but we're going to have to convert that to radians. S is the length of the arc, R is the radius. So let's just write this down. Length, radius, and this is your degree in radian measure. So I'm going to give you three types of problems today. One where you have to find the length of the arc. One where you have to find the radius given the length and theta. You're going to have to find the degree when I give you the length and the radius. So three different types of problems, and then I'll give you your assignment. Okay? Having said that, everybody's got that down. We'll write that on each problem in case you didn't get it. But that's what we're doing today. The first problem, we'll just start with something very simple. First example, example 1. This is not number 1 in the book. This is just an example I've come up with. Basically, you're given a circle, and in that circle we have a certain degree, and we're going to call that theta. The radius is going to be 6. We'll call it inches, and the length of the arc is going to be 12. Now I want to know what the degrees are. So here we have S equals R times theta, and we just fill in the information at this point. S is 12, R is 6, and we need theta. Now remember, theta is going to be in radian mode at this point, and we'll have to convert it to degrees. So we divide off the 6, and 2 equals theta. Now that's not 2 degrees by any means. And this isn't drawn quite to scale. It's pretty close, but not quite to scale. And this is obviously not 2 degrees. So what you learned yesterday, or Friday, was how to go from degree measurement to radian measurement. And that was multiplying by pi over 180. And to go backwards, we're going to multiply 2 times 180 over pi. And we're looking for degrees. This is going to be 3.14. So this will be 360 over pi, 3.14. And when you do that, you get approximately 114.6 degrees. And that's pretty close to what the picture is. I drew it somewhat to scale, but not quite. So again, S equals R times theta. Theta is your radian measure. R is the radius, and S is the length of the arc. And we're going to use these in the next section, or the next part of the section, when we do some more application style problems. So there's your first example where you had to find theta. And again, it was in radian mode. It needed to be converted into degree mode at that point. And pi is 3.14. All right, enough of that example. Let's do another one. Example 2. Here we're going to find R. So find the radius. So here's our picture, a nice circle, and we'll say that this is 2 radians. Okay, so theta, we'll just draw a generic circle, a generic arc. 2 radians, the radius we don't know, but the length of the arc is 6. We'll call this 6 feet. So again, S equals R times theta. Fill in what you know. S is 6. The radius we don't know, and theta is 2. Alright, so let's divide off the 2. And the radius equals 3. This will be 3 feet. 3 feet. The radius is 3 feet. We don't need to do a conversion. The radius is the way it is, whether it's radian or degree mode in that respect. So once you find radian, make sure theta's, radius. Once you have theta, make sure it's in radian mode when you're finding the radius. All right. now your calculator doesn't need to be in radian mode for that, and we'll talk about that here in just a second. How you know whether it's in radian mode or not. Alright, and example, we'll do one out of the book. Example 54. And this is talking about an arc that subtends this circle. Subtend means it's connected from the x-axis to the end point of wherever S is. So in this case, it's a 45-degree angle, and the arc subtends it from the x-axis to that radius. So this is 45 degrees. Notice it's in degrees. We need to convert that into radian measurement, and the radius is 10 meters. We want to know if you have a 10-meter radius, and that's about 30 feet. If you had 30 feet and you raised that up 45 degrees, how big would that arc be? How long would that arc be? So the first thing we need to do is convert theta into degrees, into radian measurement. So 45 times pi over 180. That's what you need to make sure you have, is make sure theta's in radian measurement. And if you do that, I have here that is equal to 0.7854. So 0.7854, and that's an approximation. I just took it out to 4 decimal places. So now let's do our formula. S equals radius times theta. I don't know what S is, but I do know the radius is 10, and theta is 0.7854. So we multiply that together, and the length of the arc is 7.854 meters. And you think about that, you got basically 30 feet, and you raise it up 45 degrees, that's going to be about 20 to 25 feet of the length of an arc. So that's pretty accurate. It tells you what it is, out to 3 decimal places in this case. So you had an example where you're finding theta, you had an example where you're finding radius, and then this example where you're finding the length of the arc. So 3 different examples, everything you need for the problems in the book. Make sure you're in degree mode, because we're actually doing the calculation to put something in radian measurement. You don't need to have your calculator in radian mode to do this. And remember, pi is 3.14 when we're doing the calculations. Alright, your homework assignment that I'm going to give you is going to be on page 440. So right over here, page 440. And you're going to do problems, let's see here, 51 to 59. 51 to 59 odds. And you have the answers to those. So, and again, it's just finding one of the 3 variables that you need. All right, good luck.